What is the strongest type of bridge? In order to answer this question today, we will explain the forces acting on bridge members, the components of a bridge, the materials, and the overall connections. First of all, the two basic types of physical stress are compressive stress and tensile stress. The compressive stress translates into compressive force. Consider a length of material, be it a strong stone slab, steel bar, or piece of lumber. If one were to hold each end of the material and squeeze, one would exert compressive force. The opposite of that, tensile force. As an example, if one were to pull outward, as though one were trying to stretch the material, one would exert tensile force. Weight or load in architecture is the forces applied to a structure or its components, which, if improperly designed for, can cause failure. Essentially, it is just these arrows at the top that are moving the load down below. Failures. Two common failures are buckling, which created the development of arch construction. Buckling is when a beam experiences too much tensile force and undergoes failure. This beam up top here is failing due to this load. And then the development of arch construction. Prior to the modern age, when it became possible to mass produce steel economically, architects were limited to materials lacking in tensile strength, which compelled them to develop arch construction. This converts most of a structure's tensile force into compressive stress.
The strongest type of bridge is the suspension bridge. I'm going to explain how different components of the suspension bridge work. The first component is the deck. The deck distributes loads created by the traffic and self-weight. Decks usually incorporate a truss system that helps to lower the self-weight of the deck, like an example here on the right. Decks experience both tension and compression, as you can see in this image. When loads are applied to the deck, the top will push inwards, creating compression, and the bottom will pull outwards, creating tension. Another key component of the bridge is that it needs to be somewhat heavy and rigid so it doesn't sway if there are extreme weather conditions. The next components are the cables. There are two types of cables on the suspension bridges, the main cable and the suspenders. The suspenders connect to the decking to distribute the weight of the main cables. The main cables distribute the weight of the deck, suspenders, and self-weight to the tower as well as the anchors, as you can see right here. All the cables act in tension because the components connecting to the cables are all pulling on the cables. Cables are extremely strong in tension but offer little to no compressive resistance because they have relatively small cross sections in comparison to their lengths. The towers experience compression due to the downward forces exerted by the main cables. As you can see here, the main cables are pulling down on the towers, creating compression. The towers then distribute this load into the ground. The towers need to be tall enough to keep the main cables out of the way of the deck and also strong enough to counter the forces applied by the cables. Lastly, the anchors experience tension due to the main cables pulling on them. Because of the large loads of the main cables exerting on the anchors need to be very big and heavy in order to keep the bridge from failing.
Next, we have materials. The materials that make up the anchors are large concrete blocks that help hold tension on the cables. These blocks have steel reinforcing inside of them as well. The next is the cables. The cables are high tension cables made from galvanized steel and are intertwined with hundreds or even thousands of strands. Cables can range from 1 inch in diameter to up to 3.5 inches in diameter and can withstand pressures of 230,000 psi. Sometimes there are hundreds of cables used to stand the forces of the bridge, such as the Golden Gate Bridge. Next, we have the towers. The towers can be made from different materials such as structural steel, concrete, stone, and sometimes even timber. Finally, we have the decking. Decking is primarily made of reinforced concrete. However, there are instances when they're made with steel or stone.
Alright, now that we have learned about the materials, it is time to talk about the building process. First, we start with the design. Each suspension bridge is individually designed because of the geology of where the bridge is to be located and the weight of the bridge has to support. The first part is the tower construction. This starts with the foundation. For dry land, you must dig down to firm rock and then pour the foundation. For water, you must lower a caisson, remove the water, then dig down to firm rock and pour the foundation. After the foundation, you construct the towers on top. Next comes the anchorage construction. These are cast-in-place anchors at the end of the bridge that the cables connect to. Following that is cable construction. A pilot line is strung across the cable's eventual path from one anchorage to the other so that workers can attend to the cable formation. The cable is then began to be spun by being looped from one anchorage to the other. When the proper number of loops have been spun, a jack is used to compress the bundles into a compact cable. Then vertical cables are strung for the deck to be connected to. After the vertical cables are attached, the deck structure can be constructed. The structure must be built in both directions from the support towers at the correct rate in order to keep the forces on the towers balanced at all times. In one technique, a moving crane that rolls atop the main suspension cable lifts deck sections into place where workers attach them to previously placed sections and to the vertical cables that hang from the main suspension cables. Last is the finishing. When the deck is completed, it is covered with a base layer which is usually steel plates and paved over. Painting the steel surfaces and installing electric lines for lighting are also examples of finishing steps.
Now, to summarize a little bit, the strongest bridge is a suspension bridge. So this is an example of a Japanese bridge that spans 1.2 miles long. Due to the incredible design and the super strong materials, this bridge can span that length, making the suspension bridges the strongest.